Okay, welcome back. So now we have finished our model assembling, and previously I've done all those things, those interactions and those surfaces and my sets. Here in the assembly I have some sets, surfaces, so all these things I've defined, and now I've done my interactions and my modeling my assembly as per requirements. So if you are not familiar with all these things and you wish to know where did this come from, so I strongly suggest to go back to previous videos and watch them first, and then you will be able to understand these things. Okay, so now just come to the loading step, because I do not have any kind of loads or these things. I'm only interested in frequency analysis, so I will only need just one boundary condition in my frequency step, or I just would say my initial step. It's fixed. Caster, do not want any set, just select this, done, and just fix it. Okay, and the next we need to move toward the mesh. Because these two have holes, that why it shows different color, which means that the uh, mesh control is different. For this case, this one is structured mesh, but this one is not structured. Let's just find out which type of mesh is this. So it is sweep. So we will just continue with the same thing. Let's see what kind of mesh can we generate. Just select the entire thing, and I want to mesh it at every, let's say, 4 inches, which means 0.1016. just apply it and see how much finer or coarser mesh do we have. Whole thing. Okay, so this is how now we have some, although it's also okay, but you can still generate the mesh similar to this thing by changing the element type. Let's suppose just to put this instead of sweep, advanced fonting. If you select this and okay, delete mesh, yes, done it, this thing, done it. Okay, apply the mesh again. So now you can see that it is in similar nature to the one that I've let's just do the same thing to all of these. Alright, so we might have some curvature over here. That's just the beginning. You need to play with the mesh until and unless you got accurate result. Actually, there is a study which is called mesh convergence analysis. You need to do that convergence analysis to exactly know the dimensions of your mesh. By convergence analysis, I mean that you need to vary the size of your mesh and then identify the results, and then vary your mesh and then identify your results. So at the point you will came to know that okay, this much mesh is giving me accurate result, and if I'm making my mesh more finer than that, it won't affect my result, but the computation time is too much higher in that case. So at that point you will come to know what is the maximum possible size for my mesh. Either it is at every 3rd inch, every 4th inch, every 5th inch, or something like Okay, so my mesh is now completed. Just create a job now. Alright, so no, yeah. I just remember that while I was defining my parts, I have not assigned section to those, so let's just assign sections to those. This is my brick wall. Continue. mm, Brick, yes, it is solid homogeneous and brick masonry. Okay, just repeat the same process for all of those. Base pad is concrete. Type selected here is beam. It's okay. Beam or truss. Anyhow, if you select a beam, then you also need to assign beam orientation to it. Okay, so now it is a good idea to assign beam orientation to it. Just leave it as by default and okay. I've done it. Okay, section assignment. Okay, rebar section. Okay, also assign beam orientation to it. And press enter and okay. Front wall. It's brick masonry. Okay. Side wall, it is also brick masonry. Side wall with a window. Section assignment is also brick masonry. Slab made of concrete. And again slab rebars. Beam, and that is rebar. I also need to revise the section of these things. Okay, just for the moment let's assign it, because my rebar section in my slab and okay, and also sunbeam orientation. Press enter. Okay, do the same for this thing. Alright, now these two are my slab rebars. Just coming to the profiles, I only have one profile, which is rebar die. Let's check it out in meters. Alright, so this is in meter. If I convert that to inches, so it is 0.5 inch, which I'm going to use for my base pad. But for my slab, I do not want to use the same section, because I want to use number 3 rebar for that. So you need, first of all, I need to define that. Okay, so now I have defined all those sections I required, and I also assigned those sections to each and every part that I've defined. Now that I've submitted my analysis, so let's see if it gives me any error, or if it pops up any problem. We will try to solve that. There are some slacks, for our type is okay. So here we have problems. 3 factorization in a row now failed. Check the model. It's possible that the model contain the kinetic definition. Set up the video for them. Okay, so here is the last thing that we need to take care of. There is a tie slave surface which has been used more than once, so that could be problematic. Let's just, I need to know what. Yes, here. Look at these are at different locations. Alright, so now is the time that we need to play with our step. Okay. I just want to see what on by default this one. Okay. And here we do not have anything. Okay, so first thing, let's just change the solver from Lancaster to subspace. Last time I remember when I was doing frequency analysis for my models, it gave me error because of the solver. Okay, just for the moment it's fine. Submit it again. Okay, so we need to increase the number of iteration to get the requested values. Right, let's just do that. Type, edit, vector used for iteration. Let's make it 100 and make it 200. Let's see what happens. While this will be ongoing, I just want to check my interactions, whether each and every interaction is fine. Okay, it's okay. This one is also okay. This one is okay. This is also okay. This is also fine. It's also okay. So I have one embedded region. Okay, fine. And okay. So if by checking I mean when I clicked it, so it gives me that the introduction is this. If there is a problem with the introduction, so it will pop up an error by saying that one of the element or section or surface is missing, something like that. So it might happen sometime because when you have your features, these feature datum surface, these partitions, sometimes these partitions or uh, you know uh, suppressed or deleted, so for that reason it sometime you may lose your surface or something like that, so you need to be careful with that. By the way, I've got a message here that your job is completed. Alright, so let's just check it. Okay, so here is the values of the frequency that I got. 7 5.1, first mode, second mode, third mode, fourth and fifth mode. Alright, so we are having some problem because I did not get the expected results from my models. So what I do, in the frequency steps, I change my eigensolver to AMS, and I give them a relatively higher value. Let's suppose not that much higher. Okay, that won't make any difference. Just make it 100 or 50 and 100, something like that. And I have specified some minimum and maximum. By the way, if you choose AMS, you have to specify maximum, but there is an option where you can choose the minimum frequency range. It is actually in the cycles per time, so I think it should be 0.1 hertz to, let's suppose, 50 hertz. Okay, cycle per time mean it is in the hertz, so I want my values from um, let's make it 0.01 hertz to 55 hertz, and I want my values in this range. So this is something that I've done, and in the other I leave all these coefficient by default and press OK. And okay, dismiss it. Load, nothing to do here. Mesh, it's the same, coming toward the job, and let's just submit it again. Let's see what's going. Alright, so it's now completed. By the way, from here, this data file, you can observe some result, some useful result as well. Coming to here you can see the total mass of your model, and also another important parameter here you can find the values of the frequency in radian per second and cycles per second, which mean hertz. Okay, this was just to show you, let you know. Okay, so this is how my model look like. At first I can mod. It has frequency of 9.2038 cycles per time, which mean hertz. Okay, so from this from result and stuff and frame, so you can view all the frequencies which you have asked Abaqus to give you, because if you have remember that I asked them to give me 150, but I've also specified the maximum range of my frequency, which was 25 hertz. So it will also give me values beyond that, but I do not want them. So this is something very important. The first natural frequency, it is this one. Second, apply it. So this is my second mode shape. This is the third mode shape, fourth, fifth, sixth, and just choose some random this one and last one. So this is how you can get different mod shapes and frequencies for your model. Okay, that's it. Thank you for watching it. Stay safe. Thank you. Bye bye.